We're going to talk a little bit more about reflections, rotations, and translations. We already know what those three things are and what they do to a shape because we talked about that in a previous section. So just a real quick refresh there. Remember that reflections mean that it flips the shape. So you've got like a line, an imaginary line that we're seeing, and it takes the shape and it moves it across that line, but everything becomes backwards. So it all flips the opposite direction. That was a reflection. Rotations, remember another word we used for rotations was turn. So we took the shape and we turned it around a pivotal point. So we used a point inside of our paper or something like that, or on the graph or whatever, and we used that to be our turning point that we based our rotation around. And then the last thing was that translation. Remember, translation, another word for that was slide. So we took the shape and we pushed it off to the side. So we moved it left, right, up, down, one of those three things, or four things, I should say. What we're going to talk about today specifically is something called orientation. Okay, we need to figure out what does it mean first when they talk about orientation. Like, what does that mean? What are the orientation of points? What does that have to do with this? Why is it important? Okay, orientation means it's the order of your points. What that means is when you look at a shape and you have the new shape next to it. So you have your pre-image and you have your image. Okay? If you start on your pre-image at letter A and you go counterclockwise or clockwise around that shape, it doesn't matter what direction, but you just have to be the same both times. So you're looking at your image and you're looking at your pre-image. You start both at letter A, and let's say you go counterclockwise. Okay, if you go counterclockwise and you both hit B and you keep going around, you hit C, and then you're back to A, that means that the orientation stayed the same. Now, if on your image it goes A, B, C when you go counterclockwise, but on your pre-image it goes A, C, B, where those letters get out of order a little bit, then that means that your orientation changed. Okay, so we're going to look at those three different types of transformations that we've talked about and discover whether their orientation changes or not. And they're going to give you a picture to kind of use to maybe help you along here. But I want you guys to really do a lot of thinking. And if you need to, like while you're watching this video, pause it and have time to discuss, maybe as a class or together with a partner, over what you maybe put down. Because I really want you to be able to understand what's happening in some of these characteristics, because it's going to then help you be able to recognize them in the future when you're working with problems on your own. Okay? So for reflections here, the first question that they ask is when reflecting, do some points on the shape move further than others? And describe why you think that. And then does the orientation change? And can you reflect an object and have points that don't move? If so, where are they located at? Okay, we're going to maybe do this first one together as I kind of walk you through this, and then I'm going to give you some time to really sit and think about rotations and translations. And then, like I said, take some time, pause the video, discuss it as a class or with someone next to you, and then I'll go through and summarize everything to make sure that we've got it all kind of solidified. So when reflecting, do some points on the shape move further than others? So if we look at our distances here on the picture that we have, remember we're using this line M. This is your line of reflection. Okay? If I look at A and A prime, from the line here to A, there's that distance, and it's the same to A prime. Do B and B prime move the same amount as A and A prime did? Hopefully I didn't confuse you with what I just asked there. I'm not talking about, yes, A and A prime are the same distance away from the line, and B prime are the same distance away from the line, but did the distance that A to A prime and B to B prime travel, was that the same? Hopefully you can see here that it's not. A had a little bit farther to travel than B did. B was closer to the line of reflection, therefore B prime should be closer to the line of reflection. A is a little bit farther away, so A prime should be a little bit farther away, and same with C. C is actually farthest away from the line of reflection, so C prime should be the farthest away. So in this case, yes. Sometimes shapes do have points that are going to move farther than others when you're talking about a reflection. The reason why is because the closer to the line of reflection, the less the point moves. So on that problem, B was closest. It didn't move as far as A and as C did, and that's okay. But that is going to happen when we talk about reflection. Some points are going to move farther than others. Does the orientation change? So this is that order of points that I was talking about at the beginning. So if we start at A, okay, so I'm starting here, and let's say I go this direction. So I'm going clockwise. I go A, B to C. I'm just going to write that here. A to B to C. That was my pre-image. Let's do the same thing now on the image. So you still start at A, but this time it's A prime. And we go the same direction, so we're still going clockwise. Do we get to B first? B prime first? No. We get C prime first. And then B prime. So did that orientation change? Did the order of those letters change? Yes. Reflections are always going to have the orientation change because you are turning the shape around a line. So everything's going to get flipped backwards. So the orientation is always going to change on reflections. Okay, I want you to think about this third one here with me. Can you reflect an object and have points that don't move? If so, where are they located at? What do you think about that? Can you reflect something and have a point that doesn't move at all? Some of you might think yes, some of you might think no. Let me draw a picture to maybe help you out. Talking specifically about this point right there. Now my triangles aren't perfect, okay? If I was a little bit slower and had been more purposely neat, they would look more identical, okay? But they're pretty close. If I have a point that's on the line of reflection, is it going to move when you reflect it? Think of it like this. If you stand in front of a mirror, okay, because we've talked about reflections with mirrors before. If you put your hand on the mirror, so like your palm is on the mirror, and you step away, but your hand stays, and then you come a little bit closer, so you're like extending your arm, bending your elbow a little bit here. Does your hand move? Does the reflection of your hand move? Hopefully you're saying no, okay? So when you have a point that's on the line of reflection, it's going to stay on the line of reflection. Because if you reflect it, it's going to belong over there. We actually saw that in our notes a couple days ago when we were doing those coordinate rules on the graph, where you had points that kind of overlapped, okay? That happens sometimes when we're specifically talking about like rotations and reflections, okay? So we should be able to say, yes, there are times where the points are going to stay. And if that happens, they are on the line of reflection. Okay, so now you kind of get the gist of what I'm wanting you to do and kind of the thinking that I want to see you guys go through here. So at this point, what I would suggest that you guys do is pause your video and think through these problems on your own, okay? If you're sitting in class, you guys are watching this video as a class, take some time to talk to each other. Don't be shy. Talk to your neighbor. Talk to whoever's in the room with you guys about what you think. If you're watching this video by yourself, think about your answers. Write down what you think is happening here. If there's someone that you could maybe spread your ideas to, or a classmate or something that you see later in the day that you want to talk to about it, that works too. But I just want you guys to really just take some time to sit and think through these. And when you're ready to see what the answers should be, then you can go ahead and resume watching this video. Okay, so go ahead and pause here, do your thinking, and then come back and finish watching. All right, hopefully you've had some time to get through all of these and you've really thought through and maybe had some good discussion with someone or as a class over what you guys think, and you're feeling pretty confident about your answers, okay? So the next one we're going to talk about is rotations. Let me scoot this back down and we're going to need that picture. So when rotating, do some points on the shape move farther than others? Hopefully you guys said yes. Okay, if you are closer to the center of rotation, the less a point moves. Hopefully you saw that on your picture over here. So I would say points C and C prime are pretty close to that center of rotation, that O that we're using there. So this distance here, like C to C prime, is that little arc. If I pick that up and let's say I try to move it here and I slide it up onto B, you know, you can see it doesn't even reach to B from B prime. So definitely C moved a less amount than B did, or even than what A did. So that's why that one should have been a yes. Does orientation change? So if you started at A and we went clockwise, you went A, B, C. Over here, if you started A prime and you went clockwise, was it the same? Hopefully you said yes again. Okay, A prime, B prime, C prime. So in this case, no, the orientation does not change. And again, that's going to be true. All of these characteristics are going to be true all the time when you do reflections, rotations, and translations. Okay? Can you rotate an object and have points that don't move? If so, where is it located at? You should have said yes. And that point would be on the center of rotation. Okay, so again, I'll draw a little picture here. Let's say I moved, I rotate that triangle around. Again, it's not perfect, but it gets the idea across here. If the point that you're rotating around is on the shape, then it's going to stay there. So if the point is on the center of rotation, it's going to stay. It's not going to move. All right, now let's go through translations. Okay, so when we talk about translating, do some points on a shape move farther than others? Hopefully you said no to this one. Okay, if something gets pushed, all of it moves. Okay, if I was standing in the front of the room and someone came barreling in through that door and hit me, my whole body is going to move with that impact. My feet aren't going to get left behind. Every part of me is going to move, okay? That same thing is happening with a translation. When you slide the shape, all the points slide, okay? They all slide. All right, so we should have said no. Orientation, does orientation change? Again, I would look at the order of the letters. So if we start at A, again, I'm just keeping it consistent with the direction I'm going. It doesn't matter, though, if you switch it around. If I go A to B to C, on the other shape, we have A prime. That one also is going to be the same. A prime to B prime to C prime. So no, orientation did not change. Okay? And the last question here, can you translate an object and have points that don't move? We already talked about that, right? No. If someone came in and hit me, you know, tackled me from the side, all of my entire body's going to move. Nothing's going to be left in that same location. So if you're translating something, points are all going to move the same distance. Points are going to all have to move. They can't, nothing can stay where it is. Okay, and then the orientation doesn't change. So it's just a solid no all the way across there.